Here's an example of a glacier called the Muir Glacier in North America. Here's two pictures taken from the same vantage point, same time of year, 1941 and 2004. This is classically what a glacier looks like in retreat. Now, the interesting thing is you don't deal with just a single isolated case, because in any given year, some glaciers will advance and some glaciers will retreat. The question is, what's happening all over the world? Well, I think the easiest way to answer science skeptics, and this is true whether it's evolution, climate change, or whatever, is with more science. So let's look at some more science. How about we check the status of every single glacier in the world? That should surely be the right way to do it. Now, I'm not a climate scientist, but to my amazement, when I dug into this research, there turns out to be a World Glacier Monitoring Service, believe it or not, that has been doing exactly that, checking the status of every large glacier in the world for quite a few years. Here are some of the glacier data that they have from various places. So this is indeed a worldwide sample. And here's a summary of their work that goes back in some cases as many as 7 decades, year by year in this direction. And in any given year, there's a bar graph. And the bar graph shows how many glaciers in that year advanced in various regions of the world, the Arctic, North America, Central Asia, Antarctica, Central Europe, Scandinavian. So how many advanced, and how many retreated? The ones that advanced are shown in blue. The ones that retreated are shown in red. And what you see is a consistent trend of glacial retreat. Look, for example, worldwide. The red is the number of glaciers in that year who retreated, and the blue are the number who advanced. And you can see that for every single year, going back decade after decade, more glaciers are retreating than are advancing. Now, you can find some that are advancing. And you might say, see, no real global warming. This glacier's bigger. But look at the overall trend in the overall data. Now, you can actually look at the data in a different way. You can calculate the cumulative mass. In other words, what is the cumulative ice mass of all the glaciers in the world? And it turns out, whether you take the average of all glaciers or you take special reference glaciers, which are considered to be very important, what you see is the mass of those glaciers going down and going down and going down, and the melting is accelerating in the last 10 years. All of this is real data. Now, that's just ice. Those are just glaciers. Let's look at something else. Let's look at surface temperatures. Now, these are not inferred. These are not tree ring data. These are thermometer measurements. So these are instrumental measurements, and they are made by that noted left-wing think tank, NASA. So NASA has made all of these measurements. And what you see in any given year, look at the way the data with the thin red and thin blue lines bounces up and down. Some years are a whole lot warmer, and some years are a whole lot colder. And you know that. Some years you have tough summers, some years you don't. Some years you have brutal winters. In New England this past year, we had the mildest winter that I can remember. The year before that, we had 72 inches of snowfall. So that's a real difference between these two. So it varies from year to year. So they bounce up and down. What you could, if you're looking for a trend, what you should do is average them out on a 5-year mean. That's the dark red line. Here it's not so rough. And what you see in the northern hemisphere is a dramatic increase in surface temperatures in the last few years. In the southern hemisphere, not so much a dramatic increase, but the trend is still the same towards increasing. Now notice the thin lines up here. The warmest year on record, I think this was 1998. Some columnists have said, see, since 1999 we've had no global warming on the basis of the fact there's the warmest year. But the trend is very clear. And here's what NASA, and NASA really is unbiased on this, what NASA said about this. First of all, 2009 was the second warmest year on record. And it was also the end of the warmest decade ever recorded in recent history. So we got glaciers melting. We have the warmest decade on record in terms of surface temperatures. Now let's look at something else. Why would this be happening? Well, there are two other trends that are very clear. One is we're engaged in a global experiment that every year increases the amount of carbon dioxide in our atmosphere. And in fact, there were about 240 parts per million carbon dioxide in the atmosphere at the beginning of the Industrial Revolution. By the time the youngest people in this room today are ready to retire, we will have doubled the concentration of carbon dioxide in our atmosphere. Now, I'm an experimental biologist. I think that's a really cool experiment. And what I mean by that is take an essential gas to life, like carbon dioxide, double its concentration, and see what happens. And as an experimentalist, I can't wait. I just wish the experiment was not being done on the planet on which I happen to live, because I wonder what those effects are going to be. But I think it's irresponsible to expect that you could double the concentration and expect to have no effect. Of course you're going to have an effect. And perhaps even more dramatic, although it's leveled off recently, has been the increase in methane. Now, why do I point out carbon dioxide and methane? Because a number of facts. Number one, their concentrations have risen steadily. Number two, and this is just a fact of physics, both of these gases block infrared radiation from escaping through the atmosphere. That's what cools us off at night. So both of these gases in the atmosphere act like a lid that keeps heat-carrying infrared radiation inside. And that's a clear connection to what's going on with surface temperature and with glaciers. So a warming Earth is simply an expected, a very straightforward result of changing the composition of our atmosphere. Now I want to show you one more parameter that probably doesn't matter in Kansas, but matters in another place, and that is the Greenland ice sheet. And what you see, the Greenland ice sheet melts along the coast every summer. Here's where it melted in red in 1992. It melted much farther in 2007. And you'll notice from year to year, the extent of the melting bounces up and down. Some years you get a big melt, some years you get a small melt. But is there a trend? You bet there is. The trend is towards more and more melting. And then finally, and this is the slide I thought I was introducing, this matters to people living on the coast. The extent of the northern pole Arctic sea ice melting in the summer is extraordinary. The United Nations actually had a projection on how much that sea ice would melt. It turns out in recent years the projection was quite wrong, and the melting of sea ice has been much more dramatic than anyone expected. Now it's been so dramatic that the American Navy and the Russian Navy, and these are hard-nosed, practical-minded people, they are both expecting that within a decade and a half in the summer there will be no sea ice in the Arctic. And therefore it'll be possible to circumnavigate the globe through a polar route. And both navies are making plans to get their ships up there to take control of that open sea when it opens in the summer. So this is something that militaries around the world are planning for. And as I say, these are very practical people. Here's something that, again, might not matter in Kansas, but I live 4 miles from the coast in New England. And boy, this matters to me. These are the results of tide gauge measurements of sea level. And what you can see is since 1970, the sea level has risen worldwide by about 8 centimeters. Now, I don't know if any of you speak metric, but 8 centimeters is about that much. No big deal. However, if this doubles or triples in the years ahead, and certainly the trend suggests it is going to continue, this is really going to change coastline. If sea level rises about 3 meters, for example, basically you're going to be able to do something that I've always dreamed of, which is go to Disney World in Florida and have the beach right there. That's really all that's necessary. So what do we have? We have a consistent picture. All the data show warmer surface temperatures, more glaciers melting, Arctic ice melting, and the ocean level rising. All of these are consistent. And what I do agree